This is Pre-Algebra Lesson 5.6. Now, the title of 5.6 is called Work Backwards. So this is one of the sections that is all story problems. And this is one of the ways that they want you to solve a story problem by working backwards. So this says, math strategies in action. The Long-Leat Hedge maze in England was designed in 1975. The hedges are so high you can't see over them unless you stand on one of the wooden staircases placed throughout the maze. Once you find the center of the maze in its 1.7 miles of pathways, you have to remember the path you followed and work backwards to get out. Very interesting. That would be kind of cool. So, visitors to the Long-Leat Hedge maze often take 90 minutes to reach the center, and then you have to remember your way out to work backwards. So working backwards from known information will sometimes help you solve a problem. So here's the real world problem. You are planning to go to a baseball game that starts at 1 p.m. You want to arrive half an hour early. Your walk to the train station is about 10 minutes long. The train ride to the city takes 3/4 of an hour. After you arrive in the city, you will need to walk for about 10 more minutes to get to the stadium. What time should you plan to leave? So, this is an awesome problem. This happens all the time. I work backwards on, okay, if this time starts at here and I need this to get ready, then what time do I leave at? So I do this a lot. So, here's one way that they do it. They used clocks as kind of a visual and worked backwards. So, move the hands of a clock to find your departure time. So the game starts at 1. So you want to arrive at the stadium 30 minutes before that, so that's 12:30. And then the train arrives 10 minutes before that, so at 12:20. And then the train departs and it takes 45 minutes, so from 12:20 all the way to 11:35, that's 45 minutes. And then you need another 10 minutes to walk. So you should leave your house at 11:25. So it was just all working backwards. So check whether the departure time is reasonable. Find the total time needed. So 10 minutes for the walk, 45 for the train, 10 and 30 is 95 minutes. So they added it up and then they subtracted it from the time that we found, or added it to the time that we found, and that would get you there right at 1 o'clock. So, try this on your own. Suppose you must be home by 6 p.m. If the return trip takes the same amount of time, how long can the game run in order for you to be at home on time? So, remember, here's the things that you need to know. So, you walk to the train station is 10 minutes. So the walk is 10 and the train ride is 45. So the walk is 10 minutes. The train ride is 45 minutes. And then let's go back. And then you'll need to walk for another 10. And then I think that's it. You'll walk for another 10. So if you have to be home by 6, if the return trip takes the same amount of time, so try this problem and see what you get. All right, so if I want to be home by 6, I'm going to start at 6 o'clock and I'm going to work back. Minus 10 minutes for the walk, so that would give me at 5:50. Minus 45 minutes for the train. This is for the walk from the train station to your house. 45 minutes for the train, so that equals 5:05. And then 10 minutes for the walk from the stadium to the train. So then that would be 4:55. So you should leave the game by 4:55. Now, you probably wouldn't leave that late because the train doesn't come the minute that you get there. And you might come into a couple different things. So at least you would have a ballpark area or amount of time that you should be there. So That is it for your notes.